with increasing and decreasing functions, basically if I give a given function like this, and I say the function is increasing when the gradient is positive, well, in terms of calculus, what does that mean? If the function is increasing when the gradient is positive, it means that the gradient function is greater than 0. And we know how to calculate the gradient function by deriving it. What about f of x is decreasing when the gradient is negative? Okay, well that means that the gradient function is less than 0, because less than 0 means negative. Okay, so we know how to derive a function, and we know that the gradient at a minimum or a maximum is going to be 0, but we also have to include these concepts as well. Okay, so this graph right here, if I say, when are the values of x increasing on this function here? If I'm given the graph, I don't necessarily need to do calculus. I don't need to do calculus just yet by just looking at the curve, because the function is increasing when the gradient is positive. So I look at all the places where the gradient is positive. It's positive going up to -3. This part's not positive. That's a negative gradient. And everything past +2. Okay, because that has a positive gradient, and that has a positive gradient. So to write that and with values of x, all right, so for this curve we'd say, well, this function's increasing when x is less than -3 and x is greater than 2. And we have to use these inequality signs, and we don't want to use any equal signs, because when x equals -3, well, that's a 0 gradient. And when x equals 2, that's a 0 gradient as well. So anything more than that is going to be a positive gradient. What if we're not given the graph, we're just given the equation of the original function? Okay, so for our first example, it says, for what values of x is this function decreasing? I don't have the graph, I don't have the picture of the graph, so I've got to do some calculus, and I've got to look at the derivative of when it's decreasing. All right, so what does decreasing mean? The gradient function is less than 0. We differentiate this original function here, and we get f dash x equals 2x plus 4. By now, we should be able to differentiate no problem. And we don't set it equal to 0. We set it less than 0. Okay? So we say 2x plus 4 must be less than 0. Now we just solve for x. And that will tell me the values of x on the curve when it's decreasing. That would be 2x is less than -4. Divide both sides by 2. My sign doesn't switch direction here because I'm dividing by a positive, not a negative. A -4 divided by 2 gives me -2. So that's an inequality. Let's look at another example. Okay, so for what values of x is this function increasing? That means the gradient function has to be greater than 0. So y dash or dy by dx is greater than 0. Differentiate this equation, and this equation, when I differentiate this differentiates to 0, this differentiates to -2, and this gives me minus 2x. So that is my gradient function right there. And I'm going to say, okay, it's increasing, so this has to be greater than 0. This expression right here, set that greater than 0. Like that, and just solve for x from there. Shift that -2 over to the other side, and I get -2x is greater than +2. And here's an example of when my sign is going to change direction, because to get x by itself, I'm dividing by a -2. So when I divide by a -2, that sign changes direction to get me that inequality. Okay, so what that answer means, it means all points on that curve, this one, where the x value is less than -1, it'll have a positive gradient. Positive gradient means that that function's increasing. Okay, one more example. So how to find out if it's increasing is to find the gradient function first. So the gradient function is differentiated, 4x minus 7. And the gradient at x equals 3 is I substitute that into the gradient function. And that's what the gradient is at x equals 3. And it's, I think 4 times 3 is 12. Take away 7. Gives me, so what this means, right. So what this means is that 5 is a positive number, therefore the function is increasing. And I'll write that out since it says explain. Okay, 5 is a positive number, a positive gradient, therefore it's increasing when x equals 3. The gradient's 5 when x equals 3. Okay, so that'll get us on our way.